What if everything we've been told about alien life is wrong? Scientists just built an AI that simulates 1,000 ways life could survive in the universe's deadliest places, and its predictions are terrifying because according to the math, the aliens we're searching for, they might not be on planets at all. They could be floating in the clouds of failed stars, hiding in the debris of ancient superstructures, or even lurking right here in our solar system in places we never thought to look. And the scariest part? We might have already found them and missed the signs completely. Chapter 1. The Alien Detective AI. Did you know scientists just built a cosmic detective that doesn't look for aliens? It simulates them? This isn't sci-fi. It's a real AI model that's rewriting the rules of where life could exist. And its first target? A planet where oceans boil at 300 degrees Fahrenheit and bacteria might breathe poison. For decades, the golden rule was simple: find liquid water, find life. But here's the problem: water alone doesn't guarantee anything. Take K2-18b, a promising habitable world where the James Webb Telescope recently found water vapor and possible signs of life. Exciting, right? Except there's a catch. Those same chemical signatures can come from volcanoes or cosmic radiation. Dead planets can fake us out. That's where this new tool changes everything. Called the Quantitative Habitability Framework, it doesn't just look for water, it asks, could anything actually survive here? To do that, it studies Earth's toughest life forms, microbes that thrive in acid, extreme pressure, even radiation, and calculates if they could hack it on distant worlds. Its first major test was TOI-270d, a Hycean planet 70 light-years away. At first glance, it's nightmare fuel, a hydrogen atmosphere crushing down on oceans so hot they exist in a supercritical state. Think water behaving like both a liquid and gas. Old models said no chance for life, but the AI dug deeper. Turns out, Earth has microbes living in similar conditions, like the Desulforudis bacteria in deep-sea vents, surviving without sunlight or oxygen. The AI crunched the numbers and gave a 42% habitability score. Not a yes, but way higher than expected. But here's where it gets wild. While studying TOI-270d, the model flagged something weirder on its neighbor, TOI-270c. This planet showed traces of phosphine, a gas that, on Earth, is only made by life, or in labs. The AI ran 10,000 simulations and found 3 ways it could form naturally there. But one scenario didn't fit any known science. Scientists are now racing to explain it. Could it be a new type of chemistry, a flaw in the model, or something else? Because if this AI is right, we might be looking at life that doesn't play by Earth's rules. And that's just the beginning, because when researchers double-checked the data, they found something even stranger: a missing planet in the same system that shouldn't exist. Chapter 2. The Phantom Planet. Remember that impossible phosphine signal on TOI-270c? Turns out it wasn't the weirdest thing in that system, because when scientists double-checked the data, they found something that shouldn't exist: a missing planet. And what this AI model says about it will make you question everything we know about alien life. Here's what happened. While analyzing the TOI-270 system, astronomers noticed strange gravitational tugs that couldn't be explained by the 3 known planets. Digging through old telescope data, they found faint traces of a 4th world, one that mysteriously disappeared from later observations. At first, they assumed it was a glitch until the habitability model took a look. This rogue planet, temporarily dubbed TOI-270e, orbits backwards compared to its siblings. It's smaller than Neptune, but denser, with an atmosphere full of methane and no detectable water. By all standard definitions, it should be completely sterile. But when researchers fed the data into the AI, something bizarre happened. The model spit out a 28% habitability score. That shouldn't be possible. Without liquid water, how could anything survive? The answer lies in Earth's own extremophiles. There are microbes in nuclear reactors that feed on radiation, and others in oil reservoirs that metabolize pure methane. The AI found that if similar life evolved here, it wouldn't need water. It could use liquid methane like we use H2O. But the real shock came when the model analyzed the planet's heat signature. TOI 270e is radiating way more energy than it should be. There are only two explanations. Either it's geologically hyperactive, unlikely for a small planet, or something inside is generating heat. Dr. Sarah Hurst, a planetary scientist at Johns Hopkins, put it bluntly, "We've never seen thermodynamics like this outside of living systems." The AI even flagged potential chemical imbalances in the atmosphere that resemble byproducts of biological activity. Of course, most researchers are skeptical. The leading theory is that TOI 270e might be a rare carbon planet with a surface made of diamonds where chemical reactions could mimic life. But here's the catch. When astronomers went back to look for it again, the planet was gone. Not just invisible, but missing from where the math says it should be. Which leaves us with two terrifying possibilities. Either our detection methods are completely flawed, or we found a world that doesn't play by any rules we understand. And if you think that's unsettling, wait until you hear what the AI predicts is really out there. Chapter 3: The Invisible Aliens. That missing planet was just the beginning. Because this habitability model is now suggesting something radical. We've been looking for life all wrong. It's not about finding Earth 2.0 anymore. The real aliens might be hiding in places we never thought to check, in forms we wouldn't even recognize. The model's latest simulations reveal something startling. Up to 72% of potentially habitable worlds in our galaxy might not be planets at all. They could be rogue moons, abandoned megastructures, or even clouds of aerial life floating in gas giants. The AI found that microbial life could theoretically survive in the upper atmospheres of brown dwarfs, where temperatures are just right for ammonia-based life. Ancient Dyson swarm fragments, abandoned alien tech maintaining stable ecosystems. Interstellar comets with liquid water pockets warmed by radioactive decay. But the most shocking prediction: the model estimates there could be thousands of invisible biospheres right here in our solar system, not on Mars or Europa, but in places we never considered. Venus's upper clouds. The AI calculated a 39% chance of acid-resistant microbes surviving there now. Saturn's rings. Microscopic life could theoretically evolve in ice particle collisions. The Kuiper Belt. Subsurface oceans may exist in objects like Makemake, kept liquid by tidal forces. Dr. Jacob Hack-Misra, an astrobiologist at the Blue Marble Institute, explains, "We've been so focused on surface water that we missed entire categories of possible life. The model suggests we should be looking for stealth biospheres, environments where life leaves almost no atmospheric trace. This changes everything about the search for aliens." NASA's upcoming Habitable Worlds Observatory, set to launch in the 2030s, is already being redesigned to look for these invisible ecosystems. New instruments will scan for quantum tunneling in minerals, a possible alternative to DNA, silicon-based molecular chains, atmospheric patterns that can't be explained by chemistry alone. The biggest revelation? The model predicts that if we find definitive proof of alien life in the next decade, there's an 83% chance it won't be on a planet at all, but in one of these alternative habitats. So the next time you look up at the night sky, remember, the aliens probably aren't living on distant Earth-like worlds. They might be floating in the clouds of failed stars, or right here in our solar system, hiding in plain sight all along.